Hello, good afternoon. So this is Samadhan Dadav, and we are starting with the lecture number 5 of hashing, and that is for extendable hashing. So for extendable hashing, we are going to see following topics. So these are the topics that we are going to learn today. That is, what is a hash table overflow, what is closed addressing, and what is extendable hashing. So let us see first what is a hash table overflow. So a hash table overflow is nothing but when a bucket is full and we are trying to insert key or an element into that bucket. So that is called as a bucket overflow or a hash table overflow. This is also called as collision. So an overflow occurs at the time of the home bucket is full and we are trying to insert a new pair of key or element. Okay. So how we can handle this hash table overflow, which is also called as a bucket overflow or a collision. So there are different techniques. So in case of closed hashing, we handle it by open addressing. And in case of open hashing, we handle it by closed addressing. So there are three techniques of open addressing, that is linear probing, quadratic probing, and double hashing, in which we search an alternate empty location of the hash table to find out which empty location is there, and then we can place the key, okay, which has faced the collision or which has encountered a collision when a hash function has generated the index of the hash table, right? So in case of linear probing, we search linearly for an empty location. In case of quadratic probing, we add 1 square, 2 square, and so on into the existing hash key to generate the hash table. And in case of double hashing, initially we use the first hash function, and when there is a collision, a second hash function is used. Then two hash keys are used together to generate the index of the hash table, where we can check whether that location is empty or not. So this is a probing. These are probing methods in open addressing, where we search for an alternate empty location to place the key which has seen collision during hashing. After that, separate chaining is there, which is used in open hashing. So separate chaining allows you to store uh, the keys in a chain. So whenever there is a collision, you can place multiple keys in a chain, and that is implemented by linked list. So in open addressing, most of the time we use only array for implementation. And in case of separate chaining for implementation, we have to use a combination of array and linked. So that is separate chaining. So here, Maushi, so in case of extendable hashing, so it is a dynamic method of hashing. So here we use directories and buckets. Okay, so directories are used to store the pointers which points to the buckets. So directories acts like the containers for the addresses of the buckets, and buckets actually stores the data. So it is an aggressively a flexible method in which a hash function also experiences dynamic changes. So there are two main features of extendable hashing, and that is directories and buckets. So the directories actually stores the addresses of the buckets in pointers, and each directory has an ID assigned to it, which may change each time when the directory expansions occurs. Along with that, buckets also has an ID, and they actually stores the data. So these IDs which are there to directories and buckets, they are called as depth. So the IDs in case of directories, they are called as global depth, and IDs in case of buckets are called as local depth. So let us see what is this local depth and global depth. So this is how extendable hashing can be seen. So we input the data or key to the hash function. So previously hash function used to generate index of the hash table directly, but now here hash function returns the location or name or ID of a directory, then that directory has a pointer for the bucket where the key will be stored. So this is how this extendable hashing happens. Now, this is an example of extendable hashing where you can see there are 4 directories, and these 4 directories actually contains the address for the 4 buckets. So here each directory has an ID of 2 bits, that is 00, 01, 10 or 11, and these 2 bits are there to represent an ID of a directory. That is why this number of bits are equal to 2. That is why global depth of the directory is 2. Similarly, there are 2 bits to represent the buckets, and that is why local depth of the bucket is also 2. So this is global depth and local depth. So this, let us see what is this global depth and local depth. So we have seen that directories are the containers to store pointers to the buckets, and buckets actually stores the hashed keys. Okay. So global depth is associated with directories, local depth is associated with the buckets, and these local depth and global depth are nothing but the number of bits the directories or buckets are using as an ID, as an identifier. So if there are directories and they are using 2 bits to represent or to as an identifier, directory identifier, so that is global depth is 2. Similarly, if the buckets are using like 2 bits, then local depth is also 2. If there are 3 bits used as an identifier for each directory, then global depth will be 3. So this is how we can say the number of bits which are used by the hash function to categorize the directories. So, or the number of bits used as an identifier of a directory or a bucket. So if it is a identifier, number of bits used for directory identifier is a global depth, and number of bits used to identify a bucket is a local depth. So here this local depth is actually compared with the global depth when there is a bucket overflow, and then we can decide whether local depth is less than or equal to global depth. If it is less than global depth, then what to do, and if the local depth is equal to global depth, then what to do. So let us see these actions. So these are the actions which we take, that when there is an overflow, bucket overflow or hash table overflow, so we compare local depth with the global depth. If the local depth is smaller than global depth, we just perform bucket splitting. We split the buckets only, like a single bucket which is overflow is converted into 2 buckets. Okay. And if the local depth is equal to global depth when there is a bucket overflow, then we do bucket splitting. So we split the bucket which is overflowing, okay, as well as we do directory expansions. So we'll see how we do this bucket splitting and directory expansion. So bucket splitting is nothing but when the number of elements in a bucket exceeds a particular size. Like each bucket has a capacity, and if that capacity exceeds when we are trying to insert a new pair of key and values, that is called as bucket overflow. So this is the time when we go for bucket splitting. So a single bucket is split into 2 parts. So a single bucket leads to 2 buckets now. So that is bucket splitting. So when we do bucket splitting, we also split the keys into 2 buckets. Okay. For example, if there are 4 keys in a single bucket, so they are divided into 2, 2 and 2. That is in first bucket 2 and then second bucket 2. So this is how we divide the keys also during bucket splitting. And in directory expansion takes place when bucket overflow occurs. So when the local depth is less than global depth, we only do bucket splitting. But when local depth and global depth are equal, and then there is a bucket, when there is a bucket overflow, so we also go for directory expansion. So this directory expansion is performed. So it is also like if there are 2 directories, we convert those 2 directories or expand those 2 directories into 4. If there are 4 directories, we expand them into 8. So this is how this directory expansions happens. So let us see an example how this happens actually, bucket splitting and directory expansion. So consider this is an example. Initially, there are only two directories, and see, each directory has an identifier, which is a single beat. Okay, so directory identifiers are of single beat. That is why global depth is written over there, and that is 1. Similarly, a single beat is used to identify bucket. That is why local depth is also 1. Now see here, a bucket has a capacity to store 3 keys. Okay, so suppose I have hashed 16, 4 and 6. So when we are hashing a particular value, we get a hash key, which is a number, so that we are using the last digit of that number to identify the directory. So when we hash a key, we get a hash key, and from that hash key, we use the last digit to identify the directory, and that directory gives us the bucket address where we will store that key. Like hash of 4 is 100 and 100's last digit is 0. So that 0 identifies the directory 0, and directory 0 gives me the address of bucket 1. Okay, first bucket where I'm storing 4. Similarly for 6. Now let us go ahead and see what is a overflow condition. So this is the overflow condition when we can see the bucket capacity is 3. So we have already stored 16, 4 and 6. So when we hash 22, so we get a hash key that is 10110, and the last digit is 0. So that indicates directory 0. So directory 0 gives me again the address of the bucket where there are already 3 values, which is already full. So that leads to bucket overflow. Okay, so whenever there is a bucket overflow, we compare local depth with the global depth. So if the local depth is less than global depth, we just do bucket splitting. But if the local depth and global depth are equal, we do bucket splitting as well as directory expansions. So here you can see how we have done directory expansions. 2 directories are converted into 4, and now each directory has an ID of 2 bits as an identifier. Similarly, a bucket split has happened, and now 16, 4 is in one bucket and 622 are in another bucket. So this is how directory expansion and bucket splitting happens in extendable hashing. Extendable hashing allows to split the buckets dynamically, allows to uh, allows directory expansions dynamically, as well as it allows the dynamic changes in the hash function. And that is why there is no manual work. Okay, we don't have to change the size of the table during manually. Okay, this all happens automatically, dynamically during runtime, and that is why this extendable hashing is a dynamic method of hashing. So this is all about extendable hashing. Thank you.